So we talked about the SIMs and smart SIM technology and multi-carrier protection. So what does that exactly mean? So multi-carrier SIMs are just that. We work with Verizon, AT&T, and T-Mobile. Modems go out with a primary carrier, and if that network fails, there is an automatic failover to the next strongest signal that the modem picks up. Okay, so you're not reliant on one carrier. If that carrier goes down, your modem loses communication. In this scenario, you have a backup to maintain connectivity for longer periods of time, right? Besides the failover feature, the Smart SIM allows us to remotely switch carriers if a degraded network connection is present. So not all carriers work the same in all situations. It may be connected on, say, Verizon. Maybe Verizon is not the best scenario for that location. We have the ability to go in and lock onto, say, AT&T, because maybe that is a stronger option in the area. So, and we can do that remotely. We wouldn't do it without communicating with you first, but it's good to know that these data points are available and that it doesn't necessarily require a truck roll to make these tweaks. And again, the point is, 95% of your sites are working just fine. There are going to be a small handful of sites that do require special attention, and we have the tools to be able to support that and keep your systems connected. So what happens when the signal gets tough? So there's options there as well for us. So I mentioned antennas before. We do support high gain antennas. We support directional antennas. We utilize signal boosters. And the industrial grade design that we use helps overcome some marginal coverage. The idea here is to reduce as many truck rolls as we possibly can. We don't need to be visiting sites to tweak an antenna, make sure the antenna's on, swapping antennas out, right? Most states do stay connected without additional components. But again, it's nice to know that there's alternatives, and the data helps support when those alternatives are needed. We're always working with different antennas, trying to find the best in breed to ensure that we have the best antennas possible for the equipment. Always testing, looking for any little bit of edge we can gain. So there's a research development component with the flight program, ensuring that the modem is performing up to its best standards. And for the really difficult sites, we can be a site survey partner. So we have a tool we can utilize. You basically walk around and it captures cellular signals at various points in a location. And the idea is you don't necessarily need to move a modem from the production process. What you need to do is get an antenna in a location that can accept that cellular signal. All right. So just a quick example with a site survey partner. We had an issue with a large hospital in New York City where they had a ST108 application. It was in a concrete room, a story underground. Nobody was getting a cell signal in there at all. We noticed that 2 floors up there was an exposed roof. So we were able to go up to the roof, utilize the cell signal equipment, and locate that a cell tower was in a particular direction. So you're able to point a directional antenna, right? We're in the middle of a city. You want to make sure you're pointing it in the direction of the cellular antenna. We're able to point that antenna, run a cable down 2 stories to the equipment, 1 story underground, and now they have connectivity. There was a cost associated with it, but for what they were monitoring, which was they were cleaning surgical equipment. So the few $1,000s it may cost to get that all implemented is well worth the visibility and access to the data to ensure that the machine was functioning as it should be. Because one lost set of surgical equipment easily exceeds a few $1,000s. So doing the cost benefit analysis, came up with a solution that helped them stay online, connected, and have all their data visible.